All right, so here's a word problem we want to look at. And I want to talk about two different strategies when it comes to this particular word problem. The first is going to most directly relate to how we solve problems throughout the semester. The second is going to be kind of a test taking strategy. But we're going to read through this problem and say, all right, we got this formula given to us. We're given a bunch of values. We got to plug them in and solve. So we're starting with 1600, so that's our initial amount, our principal. We want it to grow to be 1764. That's our future value, our A. And we're going to do that in T years, or in 2 years, which is our T. So let's plug those values in. We have 1764 equals 1600, 1 plus R to the second power. Now this can be a little confusing because we just solved a bunch of problems like this when it came to exponential equations, and we use logarithms to solve. But remember that an exponential equation is the base is given, we know the base, it's a number, and the variable is in the exponent. That's not what's going on here. Our unknown is in the base and we know the exponent. So we got to take a step back for a second and say, oh, that exponent's a 2. This is a quadratic equation. When it came to quadratic equations, we had three different approaches we had to solving quadratic equations, and I'd given you an order in which I wanted you to approach them. The first was to say, can I easily use the square root property? And in order to easily use the square root property, we needed to have a perfect square on one side and a number on the other side. So we have to look at this equation and say, can I easily get there? And the answer is actually yes. Because here's my perfect square. The only thing throwing me off from a perfect square is the fact that I'm multiplying it by 1600. And so actually technically, since 1600 is a perfect square, we do have a perfect square on the right, but we're not going to go there. Now, just to complete the thought though, if we hadn't realized that, the next thing we would try to do is say, can I use the zero factor property? And this is again when you have a factored quadratic that's equal to 0, so that one of the factors is equal to 0. And the fallback is the quadratic formula. And the problem I see with a problem like this particular one here is people jumping right to the quadratic formula, which is legal. You can definitely get the correct answer if you do it properly. But there's a lot of steps involved. You got to square the 1 plus r correctly first, getting 1 plus 2r plus r squared. Then distribute the 1600 throughout those three terms. Then subtract the 1764 to the other side. Then apply the quadratic formula properly. That's a lot of steps with a lot of places to make errors, when realistically this problem should be really simple. So to use the square root property, we're going to try to get the squared part, the stuff I have in highlighter, by itself. So we're going to divide by 1600. Now, tip to avoid here, make sure we're dividing it because we're undoing multiplication. It's tempting to subtract it because sometimes in our brains we do subtraction because we're saying how much interest did we make. We made $164 of interest, but that's not how to solve this equation. When we're trying to solve this equation, we're trying to undo what was done. The 1600 was multiplied by the 1 plus r squared. To undo the multiplication, we got to do division. So we could go ahead and simplify that fraction on the left, but my claim is we're going to be using a calculator, so why bother? Let's just leave it like that. And now we do have a perfect square on the right. So technically we should be taking the positive and negative square root of both sides. The positive negative doesn't really make sense here, but technically in math we should, but one of those answers is going to be dumb. So this gives us the positive negative square root of 1764 over 1600 equals, now over on the right, the square root and the square undo each other, leaving just 1 plus r. We can now solve for r by subtracting 1 to the other side. Now again, the negative doesn't really make sense because if I take negative 1 minus something else, I'm going to end up with negative 2 point something. So that doesn't really make sense to me. So instead, I'm going to take a look at this problem here. Oops. So we're now going to put this in the calculator as -1 plus the square root of 1764 over 1600. We hit enter. We get 1/20th, which isn't super helpful, but remember that this button above enter moves things between fractions and decimals. So this gives us 0.05 exactly as our value of r, which of course is 5%, which is option B. Now with that said, another option we could have gone with from the beginning would have been to say, if my right hand side was 1600 times 1 plus r squared, why not just plug each of these values in and say, what do I get when I put in 3%? What do I get when I put in 5%? What do I get when I put in 8%? And what do I get when I put in 12%? And you could put each of those into the calculator and say which of these gets me closest to 1764. Now, the danger of going that route, obviously besides making errors, is a lot of times the final answer is rounded, so you're not going to get exactly that 1764. But if you use this approach in any problem, just realize that if you come really close to it, there's a good chance that you're close because